Welcome to Matzobricks. In this video I'm going to show you how to build a Matzo Layout Controller Mini. The MLC Mini is a little device that you need to control your switches, sensors and signals on your Lego train layout. It can even control level crossings with boom barriers and lights and bascule bridges. So it's a very flexible and powerful device. It's very easy to build. You can buy all the parts very cheaply off the shelf. You just need a 3D printed case for that. So join me in the Matzobricks lab and I show you how to do it. This is what I need for the MLC Mini. That's the case, upper and the lower part. That is the lid. That's a Lego plate 6x6, which you need to prepare it in a certain way. Then this is an ESP8266 strong. So the main board on which the controller is here is called ESP strong. Then we've got some connectors, 3x4 with a 90-degree turn here, and a 3mm LED and some screws. The dimension is M2 and 8mm or 10mm long. So that's what we need. Then we have a soldering iron, some solder and a screwdriver for these little screws. That's all we need. So let's mount it. Very simple. We take the main board and the connectors, and now we need to put the connectors in. We start here and we put it here in the rows from D0 to D7. Make sure that the D8 pin is not used here, because we need that for the status LED, that one here. And the other one goes on the other side from D1 to D4. And it will look like this. If that doesn't fit, which happens very regularly, it's usually because some of the connectors here is somehow in an incorrect position. Just position it carefully to the right position, and then it should be fine. Let's try it again. To put that inside here takes between 1 second and 5 minutes. So now I'm lucky it's inside. It looks good. Needs to be pressed in as much as possible. Yeah, and basically that's in. We just need to solder that, and then the major part of our complicated work is already done. So it's not very complicated what we do. So let's solder it. So what's really important then is when you've got soldered, when you've soldered your board, have a look at it with some magnifier glasses here and see if that's all correctly soldered, or if you have made a mistake somewhere, left something out or did something not very good, because now is the right point in time to correct that. But it looks all good. So this is already the main part and we've done it. So what comes next is we have to screw the lid on the upper part of the case. And we can do that wrong, because it really depends on where to place the little hole here for the LED. Talking about holes, you need to drill a 3 mm hole inside the plate right here. That's where the LED is going to come through. And you need to drill in each corner a 2 mm hole. That's very simple because Lego has already prepared some holes here which have precisely the correct diameter. So just take a 2 mm drill, 1, 1, 1, 1. And then you need to have a countersink 45 degrees and make the hole a little bit wider from the top, that the screws, when you put them in, are just on the level of the top of the studs, because then you can use it as a Lego plate, put some more Lego parts on it and just use it as it should be in the Lego system. So, coming back to the question, where is the correct position for the hole for the LED? Very simple. The LED will come into function pin D8. And we have to use the anode, that's the longer part of the LED here. That comes into D8. And the shorter one comes into the ground, which is on the outer side here. And it looks like this. Hope you can see it. And then it's easy where to put the hole for the LED. It needs to be here. And that means we have to screw it. This is the LED. And this is correct. Needs to be mounted like this. You can check it with other devices that we've already built. Yeah, and that is absolutely correct. It takes some force to put the screws in, so it's a good advice that you do it right the first time, or you will regret it. It's just level with the top of the studs. That's how it should be. Very good. Okay, so we've got the upper part of the case, including the lid. Now it's time to put the LED inside again. And put it all together. The aim is that the LED shows a little bit out of the Lego plate here, and if that doesn't happen, you can help it a little bit by pushing it with a little tool. Yep. And now the LED is well out of the Lego plate here, but it's almost a little bit too much. No? It shouldn't be higher than the top of the studs, so just take it, press it one time on the ground, and then it's precisely the correct level. And now it's time for our soldering iron again. And let's place the last two soldering points for the LED. 1 and 2. Soldering iron can already be switched off. And let's have a look at how that looks. It's not too bad, but yeah, it's a little bit too high. So we make it a bit smaller. Perfect. So all our soldering work is done, and we are almost complete with the whole assembly. We just need to put the bottom of the case in the right position on the assembly and put the 4 remaining screws into the case. And ready is our Matzo Layout Controller Mini. As easy as that.
So, shouldn't be too complicated to build an MLC Mini, I would say. I recommend to build them in series. Yeah, it's good to have one, but actually when you automate your layout, it gets big very quickly. So I recommend to build multiple units at the same time. It just increases the fun because you can extend your layout very easily without building MLC minis all the time. Let's talk about how to connect your components to the MLC mini. I've built that little demonstration layout here. It's a simple commuter layout with 2 switches and a couple of signals and sensors for each block. Let's start with the switches first. On the front of the MLC Mini, there is the power port. That's a USB port. I recommend to have a power source that can yield 2 amperes. So if you use a strong charging device to power the unit up, that should be enough. Especially when you have switches that need a lot of power for the servos. The 2 first ports on the right side here are reserved for servos. You have to put the yellow or orange cable on top and the red and black one come below it. The orientation of the switch is absolutely crucial. If you do it wrong, you will burn your device. No? It's a very easy to build device, that MLC Mini, but it has no security features like little resistors that prevent it from burning if you do something wrong. So be careful. In that example, I've connected the switch to the MLC Mini here. Then let's have a look how that works. In Rockrail, you simply click on the switch. And then, as you can see here, it flips over. You normally don't do that when you work with our Matzobrix train automation system, because what you usually do is you tell a train to move from one block to each other or to randomly move around the layout. And that's what we do here. I will command that rail bus there to go from that block to that block and see what the switches are doing. Let's have a look. Switch flipped over. Rail bus is going until he hits the final sensor, the in sensor on the block, and then it stops. So that works pretty easily. Just connect the servo to your MLC Mini and then your switches are covered. The next thing we should discuss is a light signal. These are very simple light signals from Trixbrix here. It's just 2 white LEDs that you cover with a transparent red or green 1x1 round plate. And it has a cable that looks like a servo cable. But the pin assignment is completely different. Here in the middle, you've got the constant plus terminal. It's continuous plus on that wire. And the outer 2 pins here, they are actually switched. And if you pull them to ground, they will make those LEDs light. So what you need to do is you connect the middle wire, the plus terminal, to one of the plus outlets here in the middle of the LED ports of the MLC Mini. And the outer ones come to the function pins on top here. So the signal is connected. You can also test that by just clicking on it in Rockrail, and you see that it's going from green to red and vice versa. Very simple. Again, you don't do that in normal life because you will just tell a train to go somewhere and Rockrail cares about the rest. A little demonstration, make some space. put that rail bus back in that block. And now let's take the little old rail bus here. Oh, I clicked the wrong one. Sorry for that. I think we take a faster train. Not to waste too much money. Time is money, very good. And then we take the 6 wide. And now watch the signal, I hope you can see it. And it should turn green, let the rail bus pass, and then it goes back to red. Very nicely, good. So, signals, easy if you know how to do it. That signal is a little bit more complicated. That's a form signal, yeah. So signal which has been the standard signal on all German railroads in the last century, and to power that up, you have a servo inside, which is actually switching that wing there. And you have also got a light, but it's a continuous light. There's always power on it. So you just connect it to the plus and minus terminal on the MLC Mini to start with that. And the servo is being connected again to a servo port that you can see here. So in order to move that signal, you click on the signal and rock rail as well. The symbol is a little bit different from a light signal. And if I open the signal, the wing goes up. And if I close it, the wing goes down. It's just a servo movement which is happening there. So comparable to the switch here, the logic is here wired to the signal and it moves the servo. And it can be configured in the firmware, but I'm not instructing here how to do that. You should have a look at the website. It's pretty technical and gets easily boring in videos, so I'm not doing that here. Good. Switches, light signals, form signals. What's left? Many things, but the most important one is sensors. Sensors are here. I've just published a video about sensors last week. You've probably seen it. And those sensors are also connected to the MLC Mini using the sensor ports. Right side of the controller, the last 2 ports here, these are the sensor ports. You can do something wrong because you must be very careful. The constant plus and minus terminal of the MLC Mini are just very closely together here. If you create a shortcut on those pins, you will burn the controller immediately. To prevent that, you should use for your sensors a plug that looks like that. It's a 3-way DuPont plug, and the middle plug is left out, so there is no plug inside here, just on the outer ones. That helps you to at least make it significantly less probable that you do something wrong by connecting something very badly to the connector, to the controller here. So I recommend to do that. It helps and extends the life of your MLC Mini significantly, I suppose. Very good. Yeah, you've already seen the sensors and how that works. You know how to connect them. What's left is just a note that the MLC Mini is not the only layout controller that we have designed. It's also another one that we have, that's the MLC Mega. In comparison to the MLC Mini, it's significantly larger. It has 10 by 10 studs, while the little one has only 6 by 6, and the height of the controllers also significantly more. I think it's about double the size in height of the MLC Mini, but it's also more powerful. It has 16 servo ports here for switches, form signals, also for bascule bridges, for example, and for level crossings. Then you've got 8 light signal ports here, 16 LEDs in total, and 16 sensor ports. Yes, it is more complicated to build and you need more complicated parts, but build one of those, and if you have a small or medium-sized layout, for most people, they build one of those and they automate all of their layout. So it's a very good investment, and I'm building large layouts. That's why I have a couple of them. And that is actually helping me in whatever situation I have to automate my layout. That is for large stations where you have a lot of components in a very dense area, and the little MLC Minis here are rather for simple layouts or for peripherals where you have a side track somewhere or a signal, a sensor for a block. So it just depends on the use case that you have, what controller you want to build and want to use. And of course, the challenge to build that is significantly less than building an MLC Mega, which is more complicated. So in the end, as always, I'm letting the trains run a little bit. Thank you very much for watching. And if you like the videos, please give me a thumb up and subscribe to my YouTube channel. Have a good day.